Welcome to this session on construction stages in Advanced Design 2023. We will go together first in the concept of construction stages, then we will see some examples and application in Advanced Design for examples of construction stages such as transfer beam case, retaining wall case, and added column case. So let's start first with the concept of construction stages. In conventional structural analysis, all loadings are applied at once on the complete final structure. So in the classical analysis, we have the complete full structure. Then we apply all possible loadings and loading combinations on this structure, and we analyze it. However, this is not what is happening in reality. In practice, structures are constructed in stages, story by story generally. And loadings such as self-weight, construction and finishing loads are present at each stage prior to structure completion. So when we finish each story, we have already self-weight of the story, and sometimes we have some construction loads, and even if finishing work has started in a story before the total completion of the structure, we will have finishing loads in this story. So all of this should be taken into account because it is carried by the uncompleted structure. So in addition to this, concrete is a time-dependent material, and sometimes the structural elements at certain stages are unmolded prior to reaching the concrete full strength. So structural elements will have different concrete characteristics depending on their age in each construction stage. This phenomena should be taken into consideration during the analysis of the model. For this reason, we should do construction stages in which, during analysis phase of the structure, we replicate what will happen in reality during the construction of the structure on site. So we analyze the structure stage by stage according to the complete to each stage what we have in the structure, what loads are applied on the structure at this stage, and we continue this stage by stage until the completion of the structure. Also, we should note that stage construction analysis is not exclusive to new structures under construction only. It can be also used for studying the effect of structural modifications on existing complete buildings, such as retrofitting work, changes in structural elements, and support conditions. So this, we will see some example for this in the advanced design examples that we will display in this session. Let's start with the first application in advanced design for stage construction, which is the case of a transfer beam. Let's consider this structure over here, this frame structure. It is a frame structure made of 5 stories. We have the middle column over here that presents a discontinuity. It does not continue to the foundation levels. We have here the beam that is working as a transfer beam. And the purpose of this example is to display the importance of doing a stage construction analysis for this type of structures in order to capture the real behavior of the structure. So doing a stage construction here is equivalent to the following. At stage 1, we have the construction of the first floor. We have, as we can see here, this is the first floor. These loadings represent, in addition to the self-weight of the elements, these loadings represent, let's say, construction loadings or some finishing loads. Okay. Now, if we pass to stage 2, we construct the second story, like we see here, and we have similar loadings, stage 3, stage 4, and then stage 5. This is how the structure will really behave. It is not like applying the entire load on the structure once the structure is finished, like it's being done in conventional analysis. Because here, in this case, the frame will be working as a complete structural frame like we see here. Whereas here, we can see that the frame is not completed yet. It is completed stage by stage. And this will have effect in the load distribution inside of the structure. The result of the stage construction analysis will be the result of stage 1 plus stage 2 plus stage 3 plus stage 4 plus stage 5. So for displacement, internal forces, support reactions, and everything, the results will be the sum, the cumulative sum of stage 1, stage 2, stage 3, stage 4, stage 5 until the structure is fully completed. And this will be different than the results we get by directly applying all the loads at the completed structure, as we will see in the following application in advanced design. So going to the Advanced Design 2023 user interface, let's start by constructing this frame structure. The procedure is simple. First, we select the beam element. For example, let's start with 30 by 60 beam element and C25 concrete material. Okay, so let's take this. Okay. Now, before copying the structure, let's put first supports. Okay, we consider rigid supports in here and in here. Okay, in addition to the self-weight of the structure, let's put some construction load, finishing load, etc. So the type of loads that will be present during construction stages. Okay, it's linear load. Let's consider it to be a 30 kilonewton per meter of length for the element. Okay, now we have 2 stories. We still need to have 3 more, so we do a simple copy like this. And it's done. We have now our 5 stories. Okay, so the structure is ready. Now we need to define stages in the structure, but before doing so, let me take a copy of the structure, place it aside. We will see later what is the purpose of having this copy of the structure. Okay, so let's copy this. Sorry. Okay, we will see what we will do later with this. So first, to start defining stage construction, there are many ways to do so, but first we need to define the stages. If floors were defined in the structure elements, we can use automatic assignment, automatic from here, we can see it. We will not do this case, we will do it manually to show how to do this manually. So we right click over here, add stage. As we can see, we add the number of stages we need. In our case, we need 5 stages. Okay, now let's consider the structure to add. Okay, so we have here these elements. We right click on them. These will be assigned to stage 1 and all the stages following it. So we go here to stage selection. Okay, add. Here we select current stage, selected stage and next stages, because it will be present in selected stage and next stages, and it is add. We're adding this element. So okay, excellent, it is done. Now we go here, select this. These elements will be also present in stage 2 and the following stages. So stage 2 and following stages like this. Okay, this part here will be stage selection, add, select and next stages will be for stage 3. This part here will be for stage 4 and next stages. It will be present in 4 and next stages. Okay, and this part here will be present in stage 5. It is only in stage 5, so selected stages only, stage 5. As we can see, we have the option for each stage to add element or remove an element at the selected stage, at the selected stage and next stages, select stage and previous stages, or at all stages. So here we did it for the geometry. We need also to do it for loading, but for loading, each load will be added only on one stage because it represents the stage that's being added on. So this load will be added to stage 1. Okay, we see here only we have a selected stage for loading. So stage 1, this load here will be added at stage 2. Load here stage 3. Here we will have stage 4, and here stage 5. Now, the purpose of getting this structure is that I want to do a comparison between stage construction and applying the loads directly in one analysis on the entire model. So I'm going to create this entire structure at stage 5. In other words, at stage 5, this entire structure is created and loads are applied. This will serve as comparison between stage construction and applying the load entirely on the full structure in one calculation. So I'm going to do all of this in stage 5. Okay. So we can see here that in addition to assigning like this using the right click, we can select the stage and draw inside of each stage. So when I select a stage and draw inside of it, everything I draw inside of this stage is automatically assigned to this stage. So we can see we have stage 1, stage 2, stage 3, 4, 5, stage 5. As we can see here directly it was added. Now if I want to consider the time-dependent concrete material, I need to select this checkbox over here, and at each stage I select the duration over here, which is used to identify the age of concrete in each stage. I put it over here. It is expressed in days for each stage. In my case, we will not do this. We will not consider concrete time-dependent properties. So now our structure is ready. Let's see some aspects on what we can do also in stage construction in advanced design. So for example, at each stage, let's take for example stage 5. If we select an element, we can see some elements in the properties list that are in green. This can be used to change properties at a certain stage. So let's say at stage 5 I want to change the section of this element. I can do it. I can change the section like this over here. I want to change material characteristics of the element. I can do it like here. I can select another form of concrete with different material properties if I want. If the user wishes not to consider time-dependent properties as being done in advanced design, he wants, let's say, to define his own time-dependent properties so he can change material at each stage. Also, for supports, the user can choose at each stage if he wants to modify the support conditions. So for example, here we have fixed support, but we can, for example, change it to pin support or even other supports, enabling and disabling which degree of freedom to restraint. This can be done at each stage, however the user wishes to do. Let's keep them like this now as fixed supports. Okay, so now we're ready to run the analysis. If we want to run the analysis, we can see here that we have the new, in addition to the finite element calculation, we have here the possibility to run stage by stage calculation. So if we want, let's say, to calculate only stage 5 without considering previous stages and next stages, we do this. We select here stage 1, 2, 3, or 5. But in our case, we will do only full, so we will study all cases. So for this reason, we will do finite element calculation for all stages. So we launch the calculation. As we can see, the model here is constructed stage by stage, as we can see, and we get ourselves the results. Now to display the results for each stage, we go stage by stage. So we go to stage 1. If we want to see the deformed shape of the structure, we see it here. We want to see, for example, internal forces. We go here, linear element, let's say bending moment occurring in the structure. We get here the bending moment due to the dead load plus construction loads and finishing loads. This is for stage 1, this is for stage 2, this is for stage 3, etc. So let's jump to the comparison between what's happening if we do a stage construction analysis or a direct full model analysis. So in this case, let's do the comparison. We can clearly see that here the difference in the bending moment is very clear in the side of the structure. In fact, here, because the structure is working all together and load is applied in the final form of the structure, all beams are capable of transferring the load to the frame since the frame is already completed. Whereas here, this transfer girder is supporting more loads because it's being constructed stage by stage. For this reason, it is carrying more load, this transfer girder, and for this reason, we can clearly see here that we have more higher bending moment. This is also clear if we consider the actual force inside of the element. We can clearly see that the column here is carrying more loads in stage construction than the conventional analysis. This is due to the fact that the frame was not fully completed during stage construction, and for this reason, this transfer girder with this column are carrying more loads. If we go to check the deflected shape that we have, if we go to do this, okay, and we check linear element displacements, okay, we can clearly see that here we have a higher deflection in the structure when doing the stage construction analysis. We should note that here we are seeing the cumulative results. So as we presented earlier, it's a stage 1 plus stage 2 plus stage 3, 4, and 5. If we wish to see, for example, let's consider stage 4 here alone. If we wish to consider see only the result of stage 4, this is possible. We can here uncheck the elements of cumulative results for construction stages. So unchecking this, we will see only at stage 4. So we're currently seeing the results of this structure being applied, having these loads only, without taking into consideration what happened before, if we wish to do so. So we will get back to the cumulative results. Also, the user has the option to see the envelope. So the envelope for the cumulative results, let's say for this stage and the previous stages, by clicking this button over here, we can see the envelope of results from this stage and the stages preceding it. For the second example of stage construction in advanced design, we will present the case of a retaining wall. Let's consider this building with a basement floor. Okay, and in this basement, we have, of course, a basement wall all around the structure. This basement retaining wall is constructed after constructing the foundation of the building. Now, the question is that generally it depends on the construction process being done on site. Sometimes earth backfilling is done before constructing the slab on top of this basement wall element, and in some cases the slab is constructed before backfilling. So backfilling is done after the slab construction or before the slab construction. This detail is very important in the behavior of this basement wall over here. In fact, doing backfilling before constructing the slab, the wall will work as a cantilever. Whereas doing backfilling after constructing the slab, the wall will be supported at top and bottom level, and it will have a different behavior. Doing this in a classical full model analysis, all elements will be present, and the wall will behave exactly like this. So if in the construction on site, backfilling is needed to be done prior to the construction of the slab, we should here pay attention. Usually this calculation is done in a different model, but now with the stage construction and advanced design, we can do this calculation in the same model of analysis as we will see in the application and advanced design. Going to advanced design 2023, we have created two structures, as we can see here, one on the left and one on the right. The purpose of the structure on the right is to apply the backfilling load on the structure once the entire building is completed. So to model the classical analysis just for reference, as we did in previous examples. So let's see what we did. We defined 7 stages. At stage 1, we have constructed the basement walls and applied the backfilling load on the structure prior to constructing the slab on top of these walls. So we did the backfilling before constructing the slab on top. At stage 2, we constructed the slab on pushes on top of the walls. Stage 3, we constructed first floor, stage 4 second floor, stage 5 third floor, stage 6 fourth floor, and stage 7 the 5th floor. And also in stage 7 we added this entire structure in a single run calculation. So we are doing the analysis of the entire model with the load applied over here, just to represent what a classical analysis will give as a result, as we said, for comparison purpose. So we're ready to run the analysis. Okay. So advanced design is calculating the first stage. Then now we're at second stage, third stage, fourth stage, sixth stage, sixth stage here now. And now the 7th stage, and we added also the building on the right. Now the model is ready. Let's go and see the vertical bending moment occurring in basement walls and see the difference behavior that we will get. Okay. So, due to soil pressure, we can clearly see here that the basement wall is working as a cantilever. This was expected because the backfilling work was done prior to the construction of the top slab. Using stage construction, we were able to take this into account in our analysis. Whereas if we want to see the results in a classical analysis, it's clear that the wall, this basement wall, is supported at 2 points on top due to the presence of the top slab and in bottom for bottom level where the foundations are. So here we can clearly see the advantages of using stage construction for such a case, to be able to replicate exactly the construction sequence that's occurring on the site. Using stage construction in advanced design, we are capable of studying the effects of the sequence on sites, doing this in the software. Our last example for this session will be on an already existing structure. We will present a retrofitting example in which we will add columns inside of an existing structure due to modifications that are occurring in the structure. So let's consider that we have this frame structure over here. This is a frame structure. It is supporting dead load, its own self-weight, and we have a superimposed dead load. Now we're doing some renovation work and we're changing the use of this structure. This change in use will result in an increase in the superimposed dead load on the structure. For this reason, we will try to reinforce the beams over here by adding a column. As we can see here, we added a central column over here with the increase in the superimposed loads that are applied on this structure due to a change in its use. So how to model this? We will see how we will do this using the construction stages in Advanced Design 2023. Using Advanced Design 2023, we created two construction stages. In stage 1, we have the old structure with the initial loading applied on it, and in stage 2, we have added the additional column with the additional load that is being applied on the structure. Here, the structure on the right serves as a comparison reference. We want to do a single run analysis for the entire structure like we did in previous examples. And here we directly placed in a single run analysis the loads coming from stage 1 and stage 2, just to compare between construction stages analysis and the classical single run analysis. So now we're ready to run the model. Okay, so as we see, for example, if we consider the bending moment diagram occurring in the structure, okay, we can see here we have a normal diagram in stage 1. If we go to stage 2, we can see that we have this weird shape looking diagram. This is logical, this is expected. Why? Because the support provided here, this column provided here, was not present in stage 1. It started to work from stage 2. So this is why we have this difference over here, because it only started to work from stage 2. Whereas here we can see that if a full analysis, full single run analysis was done on the structure without taking into consideration construction stages, we will get false result. Same thing, for example, if we see the actual forces inside of the elements, we can see that this column here is not carrying much as the column edges, or the edge columns over here. This is also expected because this column is added at stage 2, so this column will start working only after stage 1. Will not take any load from stage 1. It will start taking load, working from stage 2, taking loads applied at stage 2. Whereas here in the single run analysis, we can clearly see that this column took a lot of loads. If we go, for example, to see the displacement occurring in the structure, we can see here that here, of course, we got more displacement because this column did not exist at stage 1, so the structure had its deflection, and then after this deflection, the column was added. This is why we have here more deflection. So we see here the importance of using construction stages analysis in Advanced Design 2023. Of course, in these examples that we saw, we used only load cases, simple load cases, but of course this stage construction applies on a load combination in addition to load cases. Thank you for attending this session of Construction Stages in Advanced Design 2023. I will be glad to answer all of your questions now via the chatting feature.